Yeah, good evening, everyone. Good evening. Good evening, everyone. So I think in the last class we are already done this problem. I think we done this problem also, right? We done this problem also, right? Yeah. I think this problem also we done, right? This problem also we done. Let's move to next problem. I think yeah, this is the last problem. What we done? Answer for this problem is answer for this problem is. Let me write here. Yeah. In the last class, this is the last problem what we done. Actually, remember, I written unfortunately here, non-terminal, it is a terminal. I rectified also, it is a terminal. It is the terminal. In the last class, I written here, non-terminal, but actually terminal. How many terminals in the first of Z? How many terminals in the first of Y? Including epsilon. Including epsilon. See, first of Z, follow of Y. Here I think if you remember 2 plus 1 here, if you remember here 3 plus 1 here, calculate properly, it is a 2 plus 3, which is 5. Yeah, let's move to next problem. Yeah, this is the today's class first problem. This is the today's class first problem. Can you go ahead? Consider the following grammar. One grammar is given, right? About this grammar which is true. Can you go ahead? About this grammar which is true. Can you go ahead? Everyone. Everyone try. Everyone try. What is the answer for this? Everyone try. What is the answer for this? Everyone can try this. What is the answer for this? Everyone can try this. Can everyone try this? I'm going to explain. Please, can you try all the people? Everyone can try. Everyone can try. It is my sincere request. Try everyone. Consider the following grammar. Consider the following grammar. Yeah, I am giving the answer. I am giving the answer. So one grammar is given. He is asking what this grammar is. If you observe clearly, right? Let me check here. If you observe clearly, right? So is it ambiguous grammar? Can you verify? Is it ambiguous grammar? Is it ambiguous grammar or not? Can you verify? I want answer from everyone. Is it ambiguous grammar? Yes or no? Is it ambiguous grammar? Yes or no? S goes to A goes to A. So double A possible one way. Is there any other chance? S goes to SS, S replaced by, please verify which one of the following is true. Is it ambiguous grammar or not? You can check one time. Verify. So you know checking ambiguous grammar may be little time consuming, but you have to try. Is it ambiguous grammar? So verify properly. S goes to SS, S goes to SS, this S replaced by AA, this S replaced by, right, AA, A replaced by A replaced by double A, 4 A's one way possible, 2 A's also one way possible, 2 A's also one way possible, 4 A's also one way possible. So 6 A's also, S goes to SS. I think now the interesting story. I want 6 A's. Can you check here? I want 6 A's. S goes to SS, right? I can replace this S by SS, or I can replace this S by SS. I have two choices. One way is going to be S goes to SS, this S replaced by SS, right? Every time S replaced by AA, S replaced by AA, S replaced by AA. It is also same story. Here this S replaced by AA, S replaced by SS. Here also triple S, here also triple S. I think to generate triple S, where S can be AA, where A replaced by A only. So 6 A's to generate, this is the one way. 6 A's to generate, this is the one more way. Please check properly. This is the ambiguous grammar. Because of when it is ambiguous, it never be LL1, it never be LR1. Right? S replaced by SS, left S, right? In the second level, you can replace the second S or first S. If you replace the second S, right? So 6 S will be possible. If you replace the first S, 6 S possible. So I think it is ambiguous grammar. So remember this kind of story, remember. You can expand left also, you can expand right also. Most probably this is going to be ambiguous grammar. If you see at anywhere SS format, 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 it may be ambiguous grammar. Please let me know. If anyone having any doubt, please let me know. 6 years, there is a problem. 6 years, there is a problem. 2 years, no problem, only one tree possible. 4 years also no problem, only one tree possible. But 6 years, more than one tree possible. 6 years, more than one tree is possible. Tarun, please let me know if you have doubt. Tarun, please let me know if you have doubt. S replaced by SS. S replaced by SS. Where I think 3 S are there. This S replaced by AA. This A by A. This S replaced by AA. This A by A. This S replaced by AA. This A by A. So 6 A is possible. This is one way. One more way. S goes to SS. Now I am expanding right side. SS. So this S replaced by AA. This A replaced by A. This S replaced by AA. This A replaced by A. This S replaced by A. This A replaced by A. So like that you have to. Right? So it's an ambiguous grammar. Remember, it's an ambiguous grammar. From now onwards, Tarun, remember here. From now onwards, remember Tarun here. Right? At anywhere, if you see something like SS, actually to verify given grammar is ambiguous grammar or not, actually there is no algorithm. It is an undecidable problem. It is a difficult everyone know. Right? To verify given grammar is A, to verify given grammar is A, ambiguous grammar or not, is undecidable problem. It is a difficult everyone know. Through experience, I'm saying, some if you see SS kind of thing, recursion, SS kind of thing, recursion, A goes to AA, something like recursion, but side by side SS there may be a possibility, this kind of thing. Many grammars I've seen. I cannot say like this is there compulsory ambiguous, I cannot say, but through experience, I'm saying to you, right? Recursion, and double S, SS, A goes to AA, S goes to SS, like that. There may be chance of ambiguous, so please careful. So option A, so it is a MSQ. This problem is MSQ. This problem is MSQ. So A is a ambiguous grammar. So C cannot be, because of the ambiguous grammar cannot be LL1, cannot be LR1. So what about option B, option E? We'll try. Right. So let me remove this. What about option B and option E? I will try. See everyone. So he is simply indirectly is asking follow of yes. Option C, sorry, option B, option E, indirectly is asking follow. Indirectly is asking follow. I will try this. I will try this. Indirectly is asking follow. I will try. So I'm trying. So everyone see. I am trying everyone see. In the given grammar, follow of yes is what? So I'm checking now. Everyone try to understand. It is the MSQ. I am writing here. MSQ. It is the MSQ. Right? So I'm trying follow of yes. So let's check one by one. Follow of yes. After yes, what can be? B. Okay. Next one, follow of yes. Follow of yes, because of start symbol dollar. Follow of yes, no use. Follow of yes is first of yes. Follow of yes is first of yes. First of yes is equal to first of yes. First of A. A. First of A is equal to first of yes, no use. A also. So follow of yes contain A also, B also, dollar also. So B also correct. Next one. Follow of yes contain 3 elements. True. Follow of yes contain 3 elements. Follow of yes is $AB. Answer is A also, B also, E also. A also, B also, E also. This is the answer. This is the answer. Right? So this problem answer is ambiguous also. Follow of yes is $AB. Follow of E is going to be, right? Sorry, follow of yes is going to be 3 elements. So I think this is the today's class first problem. I hope you are really comfortable. Let's move to next problem. Can you try this? What is the answer? Can you try this? What is the answer? Try what is the answer for this. Everyone have to try. Everyone have to try. Everyone have to try. Everyone try. S goes to ARC, A goes to T, C goes to T. S goes to ARC, A goes to T, C goes to T. Which one of the following is true? So if you observe clearly, S goes to ARC, A goes to T, C goes to T. If you observe clearly, to generate input string, to generate the input string T, to generate the input string T, we have two parse trees. What is that one? S goes to A goes to T. That is the one way. S goes to A goes to T. This is the one way. One more thing is S goes to C, C goes to T. This is the one more way. I think it is a ambiguous grammar. So because of it is a ambiguous grammar, definitely there is a conflict. See, both CLR1, LALR1 contain conflicts. Both CLR1, LALR1 contain conflicts. So I think D is the answer. And one more thing is, nowhere is discussing about SR conflict, because in the given grammar only one variable. See, everywhere only one. There is no shift possible. If you want, you can verify. Only RR possible. First of all, it is an ambiguous grammar. It cannot be CLR1, it cannot be LALR1, it cannot be SLR1, it cannot be LR0, it cannot be LL1. Not LL1, not LALR1, not CLR1, not SLR1. It is not anyone. And some people are asking, sir, what may be the reason? Only RR conflict. Because no person having more than one, right? No production contain on the right hand side more than one symbol. So only one is possible, RR. If you want, you can verify. RR conflict is the reason for that. No RR in CLR1 and LALR1. No. No RR conflict in CLR1, but RR is there in the LALR1. No, both. So that is the reason. So it's, I think, see, whenever a problem you think, when you think that a problem, options look like very danger. When you think that problem is very danger, remember it is a very easy. If you see properly, it look like very danger. This problem look like very danger, right? But if you observe clearly, it is an ambiguous grammar. After gate exam is over, your friend will say it is an ambiguous grammar. You feel, ayyo Rama. You feel, ayyo Sita, ayyo Rama. You cry like anything. In the examination, you cry like anything. Right? This problem is very tricky problem. So normally gate exam problems are tricky problems. Try to understand. Normally gate exam problems are tricky problems. Right? Try to understand. I hope everyone is fine. Right? Fine. Let's, I think, if anyone having small doubt also, please let me know. If you don't have any doubt, in the comment, right? Can you type in the comment section? No doubt. Type in the comment section, no doubt. If you have doubt, please let me know. Everyone, if you have doubt, please let me know. If you have doubt, please let me know. If no doubt, no doubt. Thank you, Tarun. Thank you so much. Let's move to next problem. This is the problem. Which one of the following is false? This is the problem. Which one of the following is false? Can you go ahead? Try everyone. Which one of the following is false? Everyone try. Which one of the following is false? Try everyone properly. Yeah, everyone can try. Everyone can try. What is the answer for this? It is also it is a MCQ. MCQ or MSQ? Yeah, let's see. Which one of the following is false? So I'm not sure about this. I'm not sure about this. I'm not sure about this. Forget about this. I'm not sure. Forget about this. So can you say what is the answer of this? So what is the answer for this? So if you see the input string, if you see the input string DA, if you see the input string DA, S goes to SA, right? DA, right? S goes to SA, S replaced by D. This is the one way. Next one, S goes to A replaced by D. So DA possible two ways. DA possible two ways. S goes to SA where S replaced by D. S goes to AA where A replaced by D. So DA possible two ways. So given grammar is ambiguous grammar. Given grammar is ambiguous grammar. It is a ambiguous grammar. Given grammar is a ambiguous grammar. Then it cannot be LL1. It is not LR0. It is not SLR1. It is not CLR1. Which one of the following is false? All false. That is the reason I said it is a MSQ. I may be written MCQ. Sorry for that. That is the reason I cancelled. Answer is MSQ. Answer is MSQ. Which one of the following is false? So it looked like a very difficult problem, but small twist. There is ambiguity. Small twist. There is ambiguity. So given grammar is a ambiguous grammar. So answer is A, B, C, D false. Is asking which one of the following is false. In examination, they will play a game. Which one of the following is not true? Which one of the following is not false? Right? Because in the examination we have some tension. We may see not true, we may take true. Not false, we may take false. So please be careful. Don't do this mistake. In exam, you may do this mistake. Not true. He is given not true, but you are taken as a true. You may say not false. You may take it as false, but actually is given not false. So please don't do small mistakes. Please don't do small mistakes. So this is the answer for this. This is the answer for this. Right? I think answer for this one is A, B, C, D, MSQ. All A, B, C, D are wrong. So which one of the following is false? A, B, C, D false. Yeah, Tarun, let me know if you have any doubt. Tarun, let me know if you have any doubt. Tarun, if you have doubt, please let me know. Please let me know, Tarun, if you have doubt. Hello. Can we go ahead? Can we go ahead next problem? Can we go ahead next problem? Hi, Jayshree. Hi. Can we go to next problem? Everyone, please respond. Can we go to next problem? Little doubt also there, let me know. Little doubt also there, please let me know. Can we move to next problem? Do you have any doubt? Tarun, do you have any doubt? Tarun, do you have any doubt? Jayshree, you can WhatsApp me. Jayshree, this is our WhatsApp number. You can WhatsApp. I am going to help you. This is a WhatsApp number. Please ping us. We are going to help you. Right? Our team will call you. Will give the guidance. Our team will call you. Will give the guidance. This is a WhatsApp number. Right? You can call. You can message. You can message. We are going to help you. Don't worry. We are going to help you. Right? Just ping hi. So our team will call you. We will give the response. What exact problem you have. So everything they will verify. Yeah, if everyone is comfortable with this, we can move to the next one. Yeah, let's move to next. Can you try this? Which one of the following is true? This is, I think, a MSQ. It is a MSQ question. Please try everyone. Which one of the following is true? Everyone can try. Which one of the following is true? Everyone can try. Everyone try this. Everyone try this. Which one of the following is true? It is the MSQ. LL1 is a top-down parser, of course. LL1 is a top-down parser. Ambiguous grammar may be, see, ambiguous grammar may be LL1. No. Next one, LL1 grammar is LR1. Every LL1 is LR1. LR1 grammar is LL1. No. Answer is AC. Answer is AC. Venkat, you are correct. Answer is AC. Venkat, you are correct. You are correct, Venkat. Let's go to next. Yeah. If we merge states in LR1, if we merge states in LR1 parser, means CLR1, to form a LALR1 parser, to form a LALR1 parser, then it may introduce what? It is a very simple one. It is a classroom note. From the classroom note it came. If we merge states in LR1 parser to form a LALR1 parser, it may introduce what? This is the classroom problem direct. It is a classroom problem direct. If we merge states in LR1 parser to form a LALR1 parser, it may introduce. Everyone know, right? CLR1 don't have RR conflict, but after combining, LALR1 parser may contain RR conflict. So RR, SR is not the reason. SR is not the reason. Suppose assume after merging, SR came. After merging, SR came. That means before merging also SR there. So see this one. This is after, before. This is before. This is after. Before merging. Before merging is this. After merging. Remember. After. Before merging. After merging. After merging, RR came means. After merging. RR came means. Here RR may be there, may not be there. Here RR may be there, may not be there. But remember here, after merging, SR conflict came. After merging, SR conflict came. SR conflict came. So before merging also SR is there. That is the meaning. After merging SR there, before also SR there. After merging SR there, RR there. Before merging RR may be there, may not be there. Yeah, J3 you can talk. Right, you can talk. Right? So you just ping, right? Our team will contact you. They will contact me. So we will do that. We will do that, don't worry. So before, after merging, there is RR conflict. Means before maybe, may not. But after merging, SR there. Before merging also SR there. So try to understand. Answer is B. Answer for this problem is B. Yeah. Can you go to next problem? What is the answer of this? Consider the grammar with non-terminals n is equal to SC, S1 terminals. T is equal to A, B, I, T, E. With S as the start symbol and the following set of rules. Some productions are given. The given grammar is not LL1 because of what? The given grammar is not LL1 because of what? So can you try this? Everyone can try this. Everyone can try this. The grammar is not LL1. He himself mentioned it is not LL1. What is the reason? He himself is mentioned it is not LL1. What is the reason? What is the reason? Can you try, everyone? Can everyone try? Everyone. Everyone try. What is the answer? Venkat, you can try. Venkat, you can try. So those people who are preparing, get 2026 people. If you are preparing for 2026, new batches are starting, you can join. Please start the preparation early. New batch is starting, join that. Start early. If you don't start early, the problem is those people who don't start early. The problem is right. If you start late, the problem is going to be, you may say, right, sir, 5 subjects are over, remaining subjects not over. What should I do? Gate exam is 1 more month. You will say that, sir, 5 subjects are over, remaining subjects not over. What I will do? Sir, I am not able to. Right, time is not there for test series. What I will do? So many people, 90% of people will do like this. 90% of people will do like this. So if you are serious, right, new batch is starting for the GATE 2026. You can happily join in that. You can happily join in the new batch. New batch for 2026 is starting. You can happily join. Go to exampreptool.com. From there you can join. 2025 people, happily you can join. Right, rank improvement course, EPT rank improvement course. You can join RIC course. You can join EPT RIC course. You can join. 50% discount is there for the students' benefit purpose. 50% discount. Every subject 300 questions are discussed. All important things 300 questions are discussed for every subject. 2025 people happily can join RIC course. Every subject 300. I think 2 or 3 days you can finish it off. Within 2 or 3 days, one subject. Within 2 or 3 days, one subject. Like that you can complete. Total 3,500 quality questions are there. They are going to be really useful to you. Totally 3,500 quality questions are there. They are going to be really useful for 2025 people. 2026 people you can join. 2026 people or 2027 people can join in this batch. New batch you can join. If you join early, you can complete syllabus early. You will get lot of advantage. Right, now come here. Now This problem, what is the answer? This problem, what is the answer? We'll see now. This problem, what is the answer? We'll see now. This grammar is what? And one more, he is mentioned himself. It is not LL1. He himself mentioned. It is not LL1. He himself is mentioned not LL1. What is the reason? What is the reason? So any left recursion? No. Right recursion, right recursion, there is no problem. Is there any left recursion? No. It is not a contest free. There is no meaning in that. So answer is either A or C. I think one thing is true. No left recursion also. Right? Answer is ambiguous. It is ambiguous grammar. It may be ambiguous grammar. So we'll check once. Remember, checking ambiguity. Checking ambiguity is the difficult problem. Everyone know. Checking ambiguity is the difficult problem. Everyone know. Because of I done many times, to me it may be look like easy. Because of I done many times, to me it look like easy. Right? So for those people who are doing first time, they may face some difficult problem. Let's see here. Let's see. S goes to I C T S S1. This is the given grammar. S goes to ICT SS1. S goes to ICT SS1. Right? Next one. C goes to B. That is okay. Now SS1. SS1. So remember this S. This S I am replacing again. ICT SS1. So this is also going to be B. So now if you observe clearly, IBT followed by IBT, IBT followed by IBT. Okay. Now I have in my hand S1, S1. So remember, this S means A. IBT, IBT. This S means A. S means A. Okay, that is okay. That is okay. So A also okay, that is fine. Now I have S1, S1. From the S1, S1, from the S1, S1, I want, from the S1, S1, I want EA. How? I can get EA from here. I can get EA from here also. Suppose if you keep this area as epsilon, EA will come from here. If you keep epsilon here, EA will come first. I think to generate EA, after completion of this one, to generate EA, first S1 also will generate EA because S1 goes to ES, S goes to E. Or need not be EA, simply E also. Simply E also. Suppose isn't that I want to generate this input string. I am writing the input string. See the input string. I am writing the input string. Input string is going to be IBT A E. For the last E purpose, two people are fighting. EA also okay, E also okay. EA also okay, E also okay. Right? E purpose, two people are fighting. So one possibility is E purpose, this and this epsilon. One more is going to be epsilon E. There are two possibilities. So last one E, there are two ways. So it is an ambiguous grammar. It is an ambiguous grammar. It is an ambiguous grammar. This is a very nice problem. This is a very nice problem. It is an ambiguous grammar. Yeah, perfect. It is an ambiguous grammar. Perfect. Let's move to next. Yeah. One of the purposes of using intermediate code in compilers is right, increase the chances of reusing the machine independent code optimizer in other compiler. Increasing the chances of reusing the machine independent code optimizer in other compilers. Make parsing and semantic analysis simple. Improve error recovery and all. No, it's not at all. Improve the register allocation. No, not at all. So purpose of the compiler is machine independent code. Machine independent code. So I think answer is 3. Right? Question number 20, answer is 3. Yeah. Can you go to question number 21? This is the one. This is question number 21. Can you try this? Try everyone. Some code is given. Which one of the following is false? The code contains loop invariant. There is a scope of common sub-expression elimination in this code. There is a scope of strength reduction in this code. There is a scope of dead code elimination in this code. Can you try? What is the answer for this? Everyone can try. Venkat, you can try. Tarun, you can try. Jayshree, you can try. Ajay, you can try. Everyone can try. Bhuvan, you can try. Bhavesh, you can try. Try everyone. Which one of the following is false? The code contains loop invariant. There is a scope of common sub-expression elimination. There is a scope of strength reduction in this code. There is a scope of dead code elimination in this code. Everyone try. Everyone try. Everyone. Yeah, now see this one. Which one of the following is false is asking. Which one of the following is false? Now observe. Now observe here. If you observe clearly, I value 0, I value 0, j value 0, I will check this condition. I value 0, j value 0, I will check this condition. Right? I value 0, j value 0, I will check this condition. Okay, this condition, right? I will check this condition. Okay, condition is 0 modulo 2, 0. If 0, condition is fail. Next one, next to I value becomes 1. Sorry, next to j value becomes 1. J value becomes 1, 1 modulo 2. Right? 1 modulo 2. Next one, I think if you observe clearly, right? Here j changing, j modulo 2. J changing, so j modulo 2 you are calculating again and again. Now here j changing. Here is j changing. You are keep on calculating one by one. Here j changing, you are keep on calculating, right? 4 into j, 5 into I, 5 into I. If you observe clearly, this 5 into I, if you observe clearly, right? It is not changing. So this entire area, see, again and again 5 into I calculated. Again 5 into I calculated. Again and again. I is not changing. Which one of the following is false? The code contain loop invariant computation. Loop invariant computation is possible. The code contain loop invariant computation. I think so. It is true because 5 into I, 5 into I, 5 into I. So I is not changing. Why are you doing again and again? So J only changing. In the J loop, J only changing. Why are you calculating 5 into I again and again? So I will try this. See, it is I. Right? So Venkat, if you observe clearly, see this one. 5 into I, why are you calculating? Inside the J loop, why are you calculating 5 into I? So I think my request is 5 into I, you do one time here. One time you can do 5 into I, you can use it. 5 into I do here, you can use it. The code contain loop invariant computation. Contains, right? Contain. Yes, it is true, but he's saying false. Which one of the following is false? So loop invariant is possible. Next one, there is a scope of common sub-expression elimination in this code. Common sub-expression. Where is the common sub-expression here? See, 4j two times, 4j two times. You can write one time only. Two times you are doing two times. Common sub-expression elimination also possible. Next one, there is a scope of strength reduction. Yeah, everyone knows strength reduction means replacing costly operator by cheaper cost operator. 4 into j can be written as j plus j plus j 4 times. J plus j plus j 4 times. J plus j plus j 4 times. Strength reduction also possible. Next one, there is a scope of dead code elimination. There is no dead code here. If you want, you can verify there is no dead code here. Everyone is used. I is used. J is used. X will be used. Y will be used. So I think answer is fourth option. This is false. So fourth option is the correct answer. For this problem, answer is fourth option. It's a very nice problem. It's a very nice problem. For this one, answer is fourth option. For this one, answer is fourth option. Venkat, please let me know if you have doubt. Venkat, please let me know if you have doubt. Let me know if anyone having doubt. Loop invariant. The code contain loop invariant computation. True. There is a scope of common sub-expression elimination. Yes. There is a scope of strength reduction. Yes. There is a scope of dead code elimination. No. Everyone is useful here. Everyone will be useful here. So there is no chance of dead code elimination. Venkat, let me know if you are okay. Venkat, please let me know if you are okay. If you okay with this, we can move to the next problem. If you okay with this, we can move to the next problem. If you okay with this, we can go to the next problem. Everyone can try this. Yeah, perfect. Yeah, let's go here. What is the answer of this? Consider the following productions. A goes to PQ and A goes to XY. Each of the five non-terminals A, P, Q, X and Y has two attributes. S is a synthesizer attribute and I is an inherited attribute. Consider the productions A goes to PQ and A goes to XY. Each of five non-terminals A, P, Q, X and Y has attributes. S is a synthesizer attribute and I is an inherited attribute. Consider the following rules. Some rules are given. Which of the following is true? Yeah, can you try this? Everyone can try this. Everyone can try this. Everyone. Let's see how many people will give answer. Let's see how many people will give answer. So if you observe clearly, so it is the first production semantic action. It's the first production semantic action. It is the second production semantic action. First production, if you see, A goes to PQ. Second production, if you see, A goes to XY. First production is A goes to PQ. Second production is A goes to XY. If you observe clearly, If you observe clearly, see this one, y dot I is equal to, in the second production, y dot I is equal to x dot s a dot. Means y is taking from the parent, y is taking from the parent, y is taking from left sibling, no problem. But if you observe here, x dot I is equal to a dot I plus y. So x is taking from, see this one, a goes to x, y. X is taking from a also and y also. X is taking from a also, y also. I think x is taking from right sibling. X is taking from right sibling. Here, see. X is taking from right sibling. So indication that it is not L attributed. First of all, taking sibling means taking, right? Taking, see, parent taking from children. See, parent is taking from children's. Parent is taking from children. That is called synthesized. But children is taking from the parent. Children are taken from the parent or from siblings. Children are taken from the parent or siblings. From the parent or siblings. Then it is called as inherited. But he is taking from right sibling. See, he is taking from right sibling. X taking from right sibling. So it is not even L attributed also. So both rule 1, rule 2 are L attributed. Only rule 1 is L attributed. Only rule 2 is L attributed. Neither rule 1 nor rule 2 L attributed. So one thing true, rule 2 is not L attributed. Let's go to rule 1. Rule 1 is what? A goes to PQ. So see this one. P is taking from parent. Okay, fine. P is taking from parent. Okay. Next one. Q is taking from sibling also, parent also, no problem. A is taking from both the children, no problem. I think rule 1 is L attributed. Rule 2 is not L attributed. B is the answer. Rule 1 is L attributed. Rule 2 is not L attributed. Because in the case of rule 1, right? In the case of rule 1, parent is taking from the children, or children are taking either from parent or from left sibling, no right sibling. In the rule 1, no one is taking from right sibling. Check properly. I may be wrong also. Parent taking from children's. Okay. Q is taking from left sibling or parent. Okay. Next one. P is taking from parent. P is taking from parent. No problem. So rule 1 follows L attributed. Rule 1 is following L attributed, but not rule 2. So answer is B. Answer is B. So let's move to next problem. What about this? I give an answer also unknowingly. Let's see this. Let me read. Check the following statements are true or false about dynamic type checking. Right? Check the following statements are true or false about dynamic type checking. About dynamic type checking, we have to see. So I'm seeing now. About dynamic type checking, we have to verify true or false. See the option A. Type checking is done during execution. That is the meaning of dynamic type checking. Type checking is done during runtime. That is called dynamic type checking. So B. It increases the cost of the execution, of course, because when you are running, because if at all recursion, you may run the same thing again and again. So it will do the type checking again and again. If it is a recursive program, same will be executed again and again many times. So many times type checking. If you do type checking compile time, compilation is only one time, less time. If you do type checking runtime, that is called dynamic type checking. It will take more time, that is fine. All the type errors are detected. No, it is wrong. All the type errors are detected. No, it is wrong. The reason is, see, I written here also. See, if 10 condition is true, execute A. Otherwise, execute B. If condition is true, execute A. Otherwise, execute B. While running, if 10 is true, you will go to the A. Remember, in the A, there is no type problem, but in the B, there is a type problem. But it never come to B. It never come to B. If condition true, then go to A. Otherwise, go to B. If condition true, go to A. Otherwise, go to B. Suppose isn't true, you will go to A. Suppose is in the A no type error, but in the B type errors are there. He is saying all type errors are detected. No, all type errors are detected is wrong. Type checking is done during execution. It increases the cost of the execution. True. All type errors are detected is going to be wrong. So I think answer is asking true or false. Which are true, which are false. A, B is true, C is false. It's one of the nice problem. If anyone having any doubt, you can ask me. Please let me know if anyone having any doubt. Akash, if you have doubt, you can ask. Akash, if you have doubt, you can ask. Everyone. Venkat, if you have doubt, you can ask. Jaysri, if you have doubt, you can ask. Bhavesh, if you have doubt, you can ask. Bhuvan, do you have doubt? Type checking done, execution time. So that is called dynamic type checking. It increases the cost. Recursive program, you may execute the same thing again and again. Cost will increase because you are doing type checking again and again. All the type errors are detected. So it's wrong. It's wrong. Because condition is true, you may go to the if part only, you may not go to else part. But compiler is not like that. Compiler is not running the program. It will see, it will scan the total code. Wherever error is there, it will catch. Right. Now go to the next one. What is the answer of this? Consider the following SDT. Consider the following SDT. Some SDTs are given. Is asking, one SDT is given, is asking which type of SDT. If you see this one, which type of SDT? Now see this one. M is getting from, right? I think both the left siblings, no problem. C is getting from, right? A, left sibling, no problem. Check properly. C is getting from left sibling, no problem. M is getting from A also, B also, no problem. Right? I think remaining all are fine. So which type of SDT? I think it is going to be L attributed. It is a L attributed. Which type of SDT? It is a L attributed. Some people are asking, sir, is it S attributed? S means what? Synthesized only. Parents should take from children's. Parents should take from children's. It is not like that. It is not S attributed. It is not S attributed. It is L attributed. So everywhere, a person is taking from the parent or sibling, left siblings only. See, M taking from left sibling. Right? If you go over, C taking from left sibling. So no problem. It is not S attributed, but it is L attributed. Yeah. Can you try this? What is the answer of this? Consider the following SDT. Some SDT is given. Which type is asking? If you observe clearly, right? So B is taking from C. B is taking from C. B taking from C. I think he's taking from right. So L attributed is gone. L gone means L also gone. S also gone. L is the superset. L gone means S also gone. Answer is going to be none. Neither L attributed nor S attributed. Neither L attributed nor S attributed. Next one. Consider the following grammar. Some grammar is given. They are asking this grammar is what? So LL0, you no need to check also. It is anyhow fail. There is no LL0. It's fail anyhow. So given grammar is what? So it is not a LL0, you no need to check because there is no LL0. Now check the remaining things. Is it LL1? A person having more than, a variable having more than one possibility, those only check. So is it LL1 or not? I am checking. A person having more than one possibility. I think X having more than one possibility. Remaining people, no problem. First of this calculate. First of this is 2. First of this is A, which is 2. So it is not LL1. Now some people are asking, sir, what about LR0, SLR1, LALR1, CLR1? So directly you can check the CLR1. Directly you can check CLR1. So let me try. Let me try this. S dash goes to dot S, comma dollar. Okay, fine. Because of dot S, all S possibility, dot X1. From where? Here. First of remaining, so dollar. Right? Because of dot X, X possibility. Right? Because of dot S, dot X, X possibility. X goes to dot A1B, dot 2. Because of X came from here, first of remaining, 1 here. Next one. Because of dot A possibility. A goes to dot 2. From where? From here. First of remaining 1. Now understand. Now understand everyone. Everyone try to understand. Everyone try to understand. Give that one first, which will give reduction immediately. I think reduction immediately. All the people also you can give, but give that one first, where reduction will give immediately. If I give 2 as input, then what happened is, if I give 2 as input, x goes to 2 dot, comma 1. Next one, a goes to 2 dot, comma 1. So both are reduced. So what I mean to say is, when you want to check many, take that production first, which will give reduction immediately, because in the SR conflict also are there. In the RR conflict also are there. So without reduce, conflict not possible. Without reduce, conflict is not possible. So try to give that input first, which will give a reduction immediately. When I give 2 as input, x goes to 2 dot, comma 1. A goes to 2 dot, comma 1. I think both are reduced. Assume that the state number is ij. Assume jth state. If you observe the jth state properly, so in the given grammar, what are the terminals? I think 2 terminal, 1 terminal, dollar. So let me write now. 1, 2, dollar. These are the 3 people. So I will give the production numbers also. It is a production number 1, production number 2, production number 3, production number 4, production number 5. So if you observe clearly, so on the J group, forget about shift entries. Sorry, on the J group, so J on 1, which production completed? X goes to 2, so third production. So R3 I should write. Next one, A goes to 2 dot. On 1, A goes to 2 dot means production number 4. I should write R4. So this is going to be R3, R4, RR conflict. So CLR1 itself having conflict. You no need to check further. So SLR1 fail also, LR0 fail also, LALR1 fail also, because CLR1 fail. So this grammar all fail. All parsers fail. CLR1 fail means all fail. CLR1 fail means all fail. CLR1 fail means all fail. It is fail means all fail. I tried CLR because whenever many are asking, please go to CLR1, because you cannot go individually. Suppose assume you started with LR0. LR0 fail, still you have to check SLR1. SLR1 fail, still you have to check LALR1. LALR1 fail, still you have to check CLR1. First to try CLR1 is pass or not. If you lucky, CLR1 fail, all fail. So LR1 fail directly, that is okay. CLR1 also fail. And the important thing here is, please expand those first two, which will give reduction immediately. That is the conclusion what I want to say to you. Please expand that first two, which will give reduction immediately. Those things you expand first. So the answer for this problem is, right, all fail. Let's come to this. So for this grammar, using this SDT for this input string, if you draw the tree, what is the output? So draw the tree. So you may say that, sir, multiple trees possible. If multiple trees possible, it is not your problem. Right? There may be one option, multiple trees possible, multiple outputs possible. Right? So just draw one tree. That's it. From the given grammar for this input string, just draw one tree. If multiple trees are there, you can see the option. Multiple answers may be there. I am drawing one tree. Let's see. Right? I want triple A DBC. S goes to AS. Starting is this. Where A goes to A. That's okay. But I want triple A. One more time required. AS. S goes to AS. So this is A. This is also A. Now S goes to again I can expand. Again I can expand. I will get AS where A replaced by A. But there is one more option. S goes to AB also possible. Where A goes to A. Now I am at B now. Now I am at B now. Let's see. I am at B now. B goes to I think DB. Because after triple A I want D. So DB. B goes to BC. BC. Right? C goes to C. C goes to C. So triple A DBC. Triple A DBC. Triple A DBC. It's one of the tree. If anyone say multiple trees are there, it's okay. If anyone say multiple trees are there, it's okay. Because if multiple trees are there, you don't give this question. You can see the options anyhow. Now, what is the output of this? Please remember whichever left hand side onward start. Whichever is completed first, that one you have to print. Is it completed? No. To complete this one, children should go over. Is it completed first? Left people you have to give importance first. Start from top, left people give importance. A goes to A, completed successfully. What will be printed? 3 printed. First 3 printed. Because of this 3 printed. Next, I think this is over. S goes to AS. So I think it is next. I started here, but it is not over. Now, again, one more A printed. Next one, again this. One more A printed. Right, next one. B goes to DB. B goes to DB. D directly came. I think nothing will be printed. B goes to BC. B directly came. Nothing will be printed. C goes to C. C goes to C. I think 6 will be printed. After, right? So first one, let me write the output. Let me write the output. First 3 printed. Next 3 printed. Next 3 printed. Afterwards 6 printed. It is a 3. It is a 3. It is a 3. Next 6 printed. Afterwards, B goes to BC, B goes to BC, 4 printed. Next one, B goes to DB, B goes to DB, I think 5 printed. Next one, S goes to AB, S goes to AB, so 2 printed. S goes to AS, I think 1 printed. Next one, S goes to AS, 1 printed. So answer is going to be 333 64 52 11. Check properly. This is the output. This is the output. Check properly. Draw the tree. You have to start printing from the left side. Remember, production over, then only print. See, because semantic actions are there, rightmost place. 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 Rightmost place means production over, then only print. If semantic actions are middle, without production over also, you can print. If semantic actions are right hand side, leftmost place, production starting only, you can print. If semantic actions are rightmost place, you can print rightmost place. If semantic actions are middle, you can print middle. But here rightmost place means production over, then only print. The output of this problem is 333 64 52 11. Right? Perfect. Perfect. So now one grammar is given. They're asking what is the first of A, what is the follow of A. What is the first of A, what is the follow of A. In the next class, we will see that. So those people, right? If you are serious about GATE 2025, if you serious about GATE 2025, right? RIC course will be really useful to you. RIC course is really useful. 3,500 questions we are going to solve. Right? Like whatever we are solving, 3,500 questions we are going to solve. For each subject, 300. Like that, 3,500 questions, they are more than enough for examination point of view. Examination point of view, they are more than enough. Mostly they are enough. 2026 people, 2026 people, they can join the new batch. Please start now. Don't cry afterwards 5 subjects only over. Sir, I am getting test series only 10 marks, 20 marks, 30 marks. Please don't do like that. Please start now only. Please start now only. Right? Fine. Thank you so much. See you in the next class. Right? See you in the next class. Right? Remember, next class is in the EPT channel. Next class is in the EPT channel. RIC course next class in the EPT channel. Right? Please take care. Yeah. Thank you. See you in the next class.